and welcome to my YouTube channel. My name is Miss Ho and I am a physics teacher. In this video, I am going to show you how to make your own manometer for home experiments. Now, a manometer is actually a device that is used to measure liquid or gas pressure. Now, the typical manometer that can usually be found in school labs are made out of a glass tube and a wooden foundation. But we don't have to go to that extent. We can easily make our own manometer at home using materials that you can find in stores near you or even around your home. Here's what you need. You would need a transparent tube. In this case, I have managed to find a plastic siphon that's typically used for cleaning aquariums. The great thing about this is that it's all one piece, which is going to make it so much easier for us to build our manometer. I found this at Mr. DIY. It's one of those hardware stores that sell practically everything, not only hardware materials but even household items. I got this for quite cheap. I think I got this for under 3 ringgit. So if you want one, just head on over to your nearest Mr. DIY and get one of these. Now when you're looking for a tube, make sure that it's transparent because you want to be able to see the water level that's inside the tube. If you get something that's opaque and you can't see the water level, then what's the point? Also, please make sure that you get one with a diameter that is large enough for you to easily pour water in here. Let me show you this siphon. Now, this is the siphon that's also used for cleaning aquariums. However, it's not suitable for use for a manometer because even though it is transparent, the diameter of the tubing is just way too small. So imagine trying to fill this up with water. Like you wanna pump water, you could. But it's going to take so much time, it's going to get very frustrating. You might as well get one, you might as well get one where the diameter of the tubing is large enough for you to easily pour water in. Now, with reference to the tube that we're going to use, if you find a siphon that has one end just like this is perfect actually, because this part is going to act as our thistle funnel. Now, a thistle funnel is a funnel that is shaped like a thistle flower, so it's bulbous in shape. Now, this is not exactly a thistle funnel, but it can act as one. So why we want something that's a little bit round is because when you're going to use this to measure the pressure of water, you do need to trap a certain amount of air inside so that it can be compressed and can exert pressure onto the water level. Now, if you don't have a thistle funnel like this, could you just use the open end of the tube? You actually can if the diameter is large enough, because you need to make sure it's still able to trap a certain amount of air inside. If you use a tube that is too small, it will not be able to trap enough air to have high enough a compression to exert pressure onto the surface of the water inside your tube. You would also need firm material to hold up your manometer. Now, for this, I encourage you to use items that you can find around your home easily, which you can upcycle or reuse. So, try not to spend money to buy items unless you really have no choice and absolutely have to. Now, in my case, I found pieces of this foam board, which I had used and I had cut up for another craft, which I ended up not doing. So what I'm going to do is I'm going to use these to hold up my manometer. Now, if you don't have these kind of foam boards, you can also use pieces of very stiff plastic that's normally used in craft. If all else fails, you can also use cardboard from carton boxes, although I don't really recommend those because those are not very firm. They're kind of flimsy, and we have to remember that we're going to fill this up with water. And if water spills onto the cardboard is going to go soft, mushy, and it will lose its structural integrity. Now, another suggestion is that if you're very handy with wood, you can also make a wooden structure to hold up the manometer. I'm not going to do that because, in all honesty, I'm not good at carpentry. I'm probably going to end up cutting myself instead. So I'm going to avoid all forms of woodwork. But if you are very good at carpentry, by all means, please go ahead and make a wooden structure to hold up your manometer. If you're going to use wood, then you don't need some of the material which I have prepared here. In your case, you would need the wooden structure as well as metal brackets to hold the manometer onto the wooden structure. Now, if you're going to use the foam boards or cardboard that's going to hold the manometer, you would also need wire ties. Wire ties are these pieces of wire which normally come with electrical appliances. You'll find them tied up around the wires that come with the electrical appliance to keep them in one neat bundle so that it's easy to store. Most of us would normally take out the wire ties and throw them away. So if you're wondering now, oh okay, I've actually collected a few of these, what can I do with them now? Now's a great time to make use of them. You would need about 4 of these wire ties. Now, if you don't have these wire ties, an alternative that you can use is zip ties. Zip ties are these kind of ties which you would normally just put in through one end and then you pull. You don't have to get it this short, you can get a longer one and cut off the excess. These kind of zip ties are also really cheap, like one bundle is probably about 1 or 2 ringgit at most. Now if you have wire ties and zip ties and you're trying to decide which one is better, I would recommend that you use wire ties instead, because you have to remember that we're going to fill up this manometer with water, and sometimes you may need to use liquids which may require you to give your tube a thorough cleaning. So if you can remove the tube easily, it's much easier for you to clean, dry it and then put it back onto your manometer. If you use wire ties, it makes it very easy for you to open and close it back and reuse the wire ties over and over again. If you use zip ties instead, every time you have to take out your tube, you have to cut the zip tie and use new ones to fix the tube onto your manometer over and over again. Whether you're using wire ties or zip ties, get ready at least 4 of these. Also, look for a piece of firm square box which you can use to hold up and support the backing that's going to hold up the manometer. If you have no idea what you could use as a substitute, you can even use one of those plastic main card boxes. What we're looking for is something that is firm and cubic in shape in order to provide some structural support. In my case, I want to make use of this cardboard box because otherwise it's going to go to waste, so I'm going to make use of this. Also, get ready, of course, pencil, a long ruler, if you don't have a long ruler, a short one is fine, or measuring tape, scissors to cut off any excess, craft knife, and make sure you have glue gun with glue. If you don't have a glue gun, it's fine. You can also use super glue. It's just that you have to wait a little longer for the glue to set and dry before you can continue or make use of the manometer. Now before I start, I'm just going to cover up these used pieces of foam board with white paper, because otherwise it's going to be really ugly and distracting when you're trying to take readings of the manometer. In true recycling fashion, I'm going to make use of paper which I only had printed on one side and it's blank on the other side. Now I don't recommend that you use paper because yes, paper will get wet, but in my case, because this paper has a little bit of a plastic film on the top, it should be fine. Worst case scenario, I can always take out the paper and stick a fresh set on top. Now of course the next question is, how big should the board be in order to support the manometer? The answer depends on how large your siphon tube is. I'm going to show you how to best determine the size to use. If your tube is like mine and there is a rigid straight part here, we're going to ignore the rigid part. We're only going to look at the flexible section. So looking along the flexible tubing, from this point to here, we're going to divide it into about 3. You don't have to be so exact in this case because you can adjust along the way, but let's divide this to roughly into 3 sections. So what we're going to do is we're going to make our manometer based on this length. You need the board to be wide enough and tall enough to hold this section of the tube. So I'm going to just take my pencil and I'm just going to mark roughly. It's going to be roughly about this width and roughly about this height. Okay, I'm going to put this aside now because it's just rolling all over the place. So this is roughly going to be about 14 centimeters. And this is roughly about 31 centimeters. So we're going to make the marking along here and we're going to cut it. hold the tube, we're going to need a base in order to hold up that manometer structure. How big this piece should be should include not only this board as well as where the tube would be, but also to hold the box which we are going to place at the back in order to hold up the manometer. By the way, in case I forgot to mention, if the box is hollow, it would also be great, because just in case the manometer is a little bit flimsy, you can also place heavy items in here to give even further support to your manometer structure. So in my case, I'm just going to use the balance of this piece. This piece is roughly about 21 centimeters by 19 centimeters, but feel free to make the adjustments according to your needs if needed. So what I'm going to do now is I'm going to measure out where I'm going to place this backing piece. So I'm going to place a board at the back. We're going to place it roughly like this. And I'm going to use my pencil to make a marking here. Okay, so this is where the board is going to sit. We're going to cut this part out because trying to stick this just by itself will not be stable. It's going to fall over. So I'm going to cut this piece out so that this board can actually go into this supportive piece. If you have a cutting mat, it will be a really good idea to make use of one. There we go. We have a hole here. So we're just going to test if this is going to fit in. If it doesn't fit, we'll just have to make some adjustments to try to make it fit. Yeah, still need to make it a little bit wider. And it fits. Now, before we glue this in, we also need to make markings along this piece where it's going to hold the tube. Now, we're also going to have to make markings along the board here where we're going to place the zip ties to hold the tube to the board. And we're going to need to make 4 sets. So one up and one below. To make this easier, I'm just going to measure the rough diameter of this tube. It is roughly about 2 centimeters. So we're going to make markings maybe about 2.5 centimeters on either side. And we're just going to roughly place it along the board to see how far apart the tube should be. So in this case, I think it's pretty comfortable if we could place it about 3 centimeters in. So if we place it 3 centimeters in, along here, this would be 3 and 2.5. 1, 2, 3, and 2.5. So I'm just placing it one more time just to check that the bend is comfortable, because if it can't bend properly, it's not going to hold. So that looks about fine. And we're going to make another set of markings at the bottom. Now don't go right to the bottom. Place it maybe about 1/8 or 1/6 of the way down. I'm going to place it about here. Also equal 3 centimeters in, 2.5 centimeters wide, 3 centimeters in, 2.5 centimeters wide. So these are the sets of markings which I'm going to make. Now all we need to do is just punch a hole right through to the other side so that the zip tie or the wire tie can go through. It doesn't have to be a large hole. It just needs to go right through. So what we're going to do now is we're going to fix these 3 items together first as our structure of our manometer. If you don't like this, you can also of course just cover it with white paper, but I'm going to leave it as is. And how we're going to stick it all together is we're going to be using a glue gun. If you don't have a glue gun, you can use super glue. It's just that you have to leave it a bit longer for it to dry. I'm using this book as a backing for my glue gun, so don't mind the pages. So what I'm going to do is I'm going to place glue on the inside of the hole, and we're going to glue our backing to this support in the hole. So I'm going to push it in order to make sure that it goes in and it stays in. So you can see that it's pretty flimsy, it's not very stable, and that's why we need this rectangular box. So what we're going to do is we're going to glue this as support. Okay, and there we go. Now, if you're using super glue, you've got to let this dry. Now what we're going to have to do is we're going to fix this backing onto the tube. Before we do that though, let's push our wire ties through first to make sure that they're able to go through. Otherwise, you would need to punch the holes a little bit bigger in order to make sure the ties are able to get through. Alright, so this fits. So what we're going to do now is we're going to fix this tube onto our backing. And there we go. So if your tube is anything like mine and there's one rigid part in the center, it doesn't matter as long as it's not at the U-bend. Now if some of your wire ties are not long enough to be tied together, just press them down. Make sure that you've got the tube as close as possible to this backing before you press them down. If you'd like, you can also fix it with tape, but it's really not that necessary because the tube is not that heavy. And there you go, you have your own manometer. What I'm going to show you now is how to conduct an experiment using your homemade manometer. What you would need, of course, are your manometer, a ruler, preferably a long one. If you don't have a long ruler, a short ruler should be fine, or you can use measuring tape. A tall transparent bottle with a mouth that's wide enough for the funnel to go through. You would also need some water, which I've already filled up here, and a little bit of food coloring. Now the food coloring is optional, but it is highly recommended because we're going to fill up the manometer with colored water. If the water was transparent, you'd probably have a hard time seeing the water levels, and this is why we're going to be using some food coloring. You don't need very much food coloring, just a few drops, and it doesn't matter what color you use. You can choose any color you like. If you don't have food coloring, you can use other options. I know that some people may consider using cordial, because it's colored, but I wouldn't really recommend that unless you give your manometer a thorough cleaning, because if you leave something that's sugary and sweet inside your manometer overnight, you're gonna get ants the very next day. So if you don't have food coloring, feel free to explore around your house for other options of coloring that you can add to water to put into your manometer. So the very first step is to add some coloring to some water. Now in case you were wondering, I've already covered my table with waterproof tablecloth because I want to protect the surface of my table, right? And I've also filled up 2 bottles with water. This is the bottle which we're going to use for our experiment, and this is the bottle of water which I'm going to pour into this manometer. So let's start first by putting just a few drops. You don't have to put very much, you just need to get enough. So I'm just covering this up so that I can shake it and give this an even coloring. Okay, yeah, now I know it looks like mouthwash, but yeah, it's just food coloring with water. Okay. We are now going to pour this water into our manometer. We're going to do this carefully. And you should be able to see how, because of the coloring, you're able to see the water levels so clearly and so easily. Now, how much water you need to pour in? You could probably pour about half to 3/4. Don't pour all the way up, because what's going to happen is we're going to be sticking this diesel funnel into your bottle of water and the level is going to change. So you don't want it to be all the way up, because what happens is if you push this funnel in to the water, this level of water might spill over. Okay. So we're going to put this aside for future use. Now the reason why I've asked you to leave this much flexible tubing is so that there is enough flexibility for you to be able to maneuver this part of your tube. Now, of course, ideally, if you had a measuring cylinder such as the one that I have here, it would be a lot clearer and easier for you to use. Because what happens is, if you stick the funnel into the measuring cylinder, you can see, let me just get all this out of the way, you can see that as I press the tizzle funnel in, you can see how the levels of the colored water are changing. Now, not all of us have a measuring cylinder, of course. So that's why I asked you to get a tall, transparent bottle with a large mouth. If you don't get something that's transparent, it's going to be really difficult for you to be able to see the level of water which your tizzle funnel is at. So can you see how the level has changed? So the theory behind what's going on is this. The lower the depth that you go underwater, the greater its pressure. So by using this funnel, what happens is when we press this funnel to a certain level underwater, what happens is the liquid pressure has increased, and that has caused the air to compress inside this part of the tube. And that compressed air presses on the surface of this water level. So that means in this case now, on the left hand side, the pressure acting on this surface of the water is much greater than the atmospheric pressure that's pressing on this side of the tube. And that's why this water level has gone much lower compared to this side. And when we decrease the depth, meaning we lift this up, you can see how the water level comes back up. So an experiment that you guys can do in order to study the relationship between the water pressure and the depth of water is this. You're going to press this funnel at a depth under the water, and you're going to measure the difference in height of the water levels. So I would suggest you go with 5 values. For example, we could go with 5, 10, 15, 20, 25. We're not going 10, 20, 30, 40, 50 because the bottle is just not that high. So let's go 5, 10, 15, 20. Now when you measure the 5, 10, 15, 20, don't mark this level and mark 5, 10, 15, 20, because the moment you press this funnel underwater, you can see how the water level has risen. So you need to measure the depth of water from the new water level to the bottom of this funnel. So using your ruler, what you do is you measure up to 5 centimeters, leave it there, and then you need to measure the difference in the water levels over here. And then continue by pressing this down, now to 10, and then measure it again. And then 15, repeat all the way up to 25. Now a question that some people ask is, does it matter that the tube is not perfectly aligned? Because you can see that the tube is a little bit curved, and so do we need to take into account these slants? No, you do not, because you must remember that liquid pressure depends not on the length of the tube, but on the height. So all you need to do is just measure the direct height from here to here, and that will be the height you use for the difference in the water levels. The difference in the height of these water levels will represent the difference in the pressure values, or in this case, will represent the water pressure that's exerted by the water at this level. So this is how you can build your own homemade manometer. Feel free to explore more pressure values that you can measure with this homemade manometer. You can even pour 2 different liquids inside your tube and see what happens. Thank you for watching. I hope you found this video both fun as well as educational. Don't forget to click like and hit subscribe. I'll be creating videos on more home experiments that you can do out of materials you can find easily in stores near you or materials you can find around the house. Thanks for watching, and don't forget to have fun.